Hello, and welcome to this video tutorial on wall types and furring. In this video, we will be going over the methods and techniques to determine when and how to use and show furring. Since we can't talk about furring without first going over different wall construction types and typical thicknesses, we will also be covering those topics as well. We begin with discussing different wall types and their typical thicknesses. You can see in this partition schedule that there are many different types of walls we can come across. Some will be more common than others, so you will want to familiarize yourself with their typical thicknesses. The three most common wall types are concrete, CMU, and gyp walls. Most wall types can be recognized in the photos taken during the scanning, but having architectural sheets greatly increases our ability to determine the actual wall type. They can often be seen on the sheets as different hatching types within the walls. In our drawings, we will always want to nominalize our wall's thickness. However, there will be areas we want to be as accurate as possible. The three most important areas for us are the perimeter, stairs, and elevators. If you can identify the wall type from photos or from architectural sheets, we should use the actual thickness in only those areas. Areas like restrooms, electrical rooms, corridors, and especially tenant partitions should always be drafted with nominal thicknesses. CMU and concrete are the easiest to determine their correct thickness as long as we are able to scan both sides. But what happens if the scanner cannot reach one side of the concrete? This can happen for many reasons, but the most common is due to the inside being furred over. Furring is often used to finish surfaces with drywall, make space for insulation, or to level uneven surfaces. Let's look at our first example to better understand this. This building's construction type is a concrete tilt-up, which is mainly used in industrial-type buildings. Because these wall types are very consistent in their construction and thickness, it is easy to use photos and the point cloud data to determine the typical perimeter thickness and any furring that is added to the inside. This building is mainly warehouse space with some cold storage rooms and some office space. Using photos, you can see the bare concrete in most of the building. When entering the cold storage rooms, the wall material changes and can be seen here. You should be able to get the exact thickness for the perimeter, which in this case it is 8 inches. And for the furring, you will use a nominal thickness. This is an example of how not to show the perimeter. While a perimeter thickness can change throughout a building, if you are using photos, you will know that this is furring and this is the actual perimeter wall. While having bare concrete in the warehouse space is more common, let's look at an example of an office layout inside a concrete tilt-up industrial building. Our next example is another concrete industrial building. Unlike our previous example, this building is mostly office space. When you come across a building that is difficult to determine the typical perimeter thickness, it can be helpful to use rooms that are only accessible from the outside. Mechanical rooms, fire riser rooms, and sometimes egress stairs can all be used in conjunction with photos. While scanning the perimeter, they enter a few of these types of rooms, and I will use the point cloud data from there to get my typical thickness. I will then add my furring on the appropriate layer to the remainder of the building to match the point cloud data. Notice how in this photo of the egress stair, you can't see bare concrete. However, the point cloud data shows a different story. This is why using photos with the point cloud data is so important. Sometimes the concrete gets painted to offer a better finish without adding furring. Our last example is a high-rise office building. The typical floors are all glass curtain walls, and this will be used as our typical perimeter thickness. Anything the scanner picks up in addition to this on the inside will be added as furring to the correct layer. With these buildings, it is very common for the first floor to have a different layout. In this example, it is to accommodate service areas. With this project, we have the benefit of having architectural plans to be able to reference. While these plans do not have dimensions to be able to draft with, they do show wall types, and we can use this to our advantage in determining if a wall has furring on it. Most of the walls in the service area are made up of CMU, which are verified with photos. However, the walls that separate the service areas from the occupied areas have furring on them, which can be seen in the plans we have acquired and the photos from Tenant Space. You should always use all of your available resources while drafting. Do not just rely on the point cloud data. Checking Asana and the project docs folder should always be done prior to starting a project. Because there is CMU on the inside of the chiller and boiler rooms, I will use that as the main wall for those areas and add furring to the tenant side to match the point cloud data. It also happens to line up nicely with the corridor wall above the boiler room. Let's take a closer look at the stair near the chiller room. If I had started with the first floor, it would be difficult to determine this wall thickness. However, since we have the second floor completed, I copied that stair down to make sure they stack and added furring to the outside of the stair wall to match the point cloud. It is only 5/8 of an inch, but if you recall our partition schedule from earlier, you will know that most drywall is either 5/8 inch or 1/2 inch. And since this wall matches the point cloud well all the way to the core, I was okay keeping it at 5/8 inch. Notice my wall thickness is nominal after the stair ends. The last topic will be how to show furring. The thickness for furring will always be nominal because it is not part of our 3 critical areas. The layer you will show it on depends on what the adjacent areas are. If it occurs along the perimeter, you will have to first check Asana to see if our scope of work includes tenant partitions. If it doesn't, you do not have to show the furring. Only show the main perimeter wall. If it occurs near a core room, it can get a little more tricky. Get in the habit of showing the furring on whatever layer it is adjacent to. You can see in this floor plan the furring along the perimeter changes where the space classification changes from tenant area to corridor to core rooms and back to tenant area. Then, as we scroll around the perimeter to this lobby and stair, the double wall changes from core to tenant partitions because the space classification of that area also changes. To better understand layering, you can always ask yourself the question, who uses this or has access to this room? This will give you a clue as to what layer to show the walls on. This concludes our video tutorial on wall types and furring. I hope you have a better understanding of furring and when to use it. Thanks for watching.